Hey Techla homies, Fletch here. If you like this video, remember to come back every first Monday of the month for the OKC Sharp live stream, and also check out the Gen Studios YouTube channel. Like and subscribe, and let's begin. Welcome, Mark.
Hey, hello.
Hey. All right, I'm gonna. I'm
Is
gonna.
is this thing working?
It is. I'm hoping to get some feedback from the Twitch chat about the difference between your volume and my volume to make sure that we're pretty much equal. So go
Sounds
ahead and
good.
talk for a second, and I'll adjust it.
Yeah, all right. So, hello, my name is Mark Seemann. I can always repeat this introduction if you want me to repeat it later on, but my name is Mark Seemann. I'm calling in from Copenhagen, Denmark at the moment. It's 6:30 here and it's pitch black. Well, it's Copenhagen. It's a big city, so it's not really pitch black, but it could have been pitch black if it hadn't been for the city lights. How about that?
Yeah, sounds good. They're saying it sounds good inside Twitch.
All right.
So, all right. I'm glad we get to talk again. Let me pull up my notes here. Boop. Okay, so Mark, I've always been a longtime fan of yours, and so I'm going to. I've referenced your blog a number of times, blog.plo.dk. So my first
Yeah.
question is, how do you pronounce that? Is that Plo? And what's the origin of
Uh,
it?
yeah, well, if I pronounce it plur, plur, but the origin is a secret, so I can't tell you or anyone else for that matter, unfortunately.
I like that. It's a little bit
It must
scary
remain a
and
mystery.
okay. Okay, perfect. So the last thing that watched that you were part of was the .NET Rocks coverage of your book release.
Right.
So
Yes.
in that you talked about your story about bisect, about how you're using git bisect
Oh
in
yeah.
order to find an issue, and your issue ended up being, as you said inside that interview, a state-based malfunction. So I
Hmm.
believe you focus on imperative shell functional core as much as
Yeah.
possible.
True.
And could you dive into some details on what state-based mutation is and how it applies to someone who's doing imperative shell functional core type development? What is state-based mutation as it relates to
Right.
that?
Okay. Yeah. So this is a big topic, but you always stop me if I start to ramble because I have a tendency to just keep going until you stop me. But in short, state-based mutation is when we change values in place, which is a very normal thing to do in object-oriented programming. It's also a very normal thing to do in more old-fashioned procedural programming. So if you imagine, for example, that you have a for loop and you start by having some sort of a counter, and then you go through that for loop, and for each round through that for loop you increment the counter, something like that. That's actually an in-place state mutation because you're mutating, you're changing the, in this case, the value of the counter as you go along. Um, now, these sorts of very local state changes are actually not that they're not that dangerous, because if that counter variable, if that never escapes the procedure that you're within when you're doing the for loop, it's really just a local thing. And if the for loop is part of a method body or a procedure body that's not too big in itself, you can probably keep track in your head of what's the state of that count is going to be like. But in general, if you have mutable state on an object or some data structure, and let's just call them objects, you could have all sorts of procedures that change the state of the object. So we see that a lot in object-oriented programming, where we have we have some object that represents some things, and it might be a user object, for example. Let's say that we have an object that represents a user who's logged into the system, and now we want to make a change to that user object. And what we could do in a typical object-oriented fashion is to say, let's make that change. Let's change the first name, for example, if the user has decided that the first name that they have was not appropriate anymore. They wanted to change the name. We could do that, and we could say, let's change the name, inside of the object, and we change the value of the field, and that's what we call, state mutation. We change the state of the object. So one of the problems with doing that is that, as long as you consider that in a local scope, it's actually not that problematic, and it feels quite intuitive, because all the words we use about doing these sorts of things is we say we want to change the first name of the user, and so it seems quite natural. Then we should go and change the first name field on the user object. That seems very intuitive. Um, but the problem with that is that it doesn't really scale in the sense of our ability to understand larger scale systems. So when I talk scale here, I'm not talking about scalability in the sense of being able to handle millions of users. I'm more talking about the scale in the sense of a programmer being able to understand the code base as the size of the code base grows. So we can understand small state changes fairly well, but once we start to compose objects that have local state changes with other objects that have local state changes, and we compound those into larger objects that are composed of all of those smaller objects that have local state changes and so on, it starts to become really difficult for the human brain to keep track of all the stuff that's happening. And this is a common source of all sorts of defects and bugs in systems, that you've probably tried this yourself. You're passing an object as a method parameter through some method, and it goes on and does a lot of complicated things 15 levels deep into the call stack, and somewhere within level 13 in that call stack, something in a randomly or a rarely executed branch of some logic will go and in certain circumstances it'll go and change the state of the input parameter. So you're calling this method and you're thinking the input parameter is just going to be input, and you're going to receive something else as output, but unbeknownst to you, as a side effect, the input object that you passed as an input parameter also changed state, and that could really surprise you. So these sorts of things these can lead to all sorts of very difficult to understand problems in source code, and that's why this is one of the reasons why I find functional programming very interesting, is because in functional programming you basically say, oh, those local state changes, they're not allowed to happen just willy-nilly. You have to have some discipline around when they happen, and they should happen as rarely as possible.
Yeah, yeah, I love that. I was always confused by the ref parameter in the parameter list, because object references, reference objects are always passed by reference anyway. Putting ref is sort of a little bit redundant, but I love the idea now with records that I could say pass in person, my lowercase p, my person instantiated object, with, and then like open close, just an empty open close curly braces, and it's essentially saying take a copy of that struct and pass it in. Whatever they do with it, it's not going to affect me.
Right.
But I always tell people,
Right.
of course, if you are expecting to be transforming an object, which they shouldn't be doing, I agree with all the things you're saying, is just get rid of it. If you are going to, at least be descriptive to the person calling your method by putting that ref keyword on there, it could be helpful. But as Floyd mentioned, just to recap what you were saying, side effects mean in-place mutations, means headaches. It means that you're doing a lot of problems. Yeah.
Yeah, that's one thing, but another thing that's really interesting when you start to think about, so the common question at least, typically becomes, okay, if we can't change, things in place, then what do we do instead? And again, if we just go back to some, a simple example as this user object that I talked about before, what the C# language feature that you just referred to is, I suppose you're referring to this new language feature called withers, right?
Yeah. Yeah.
No? Yeah. Okay.
Yeah.
Yeah. So what that actually does is it takes a copy of the input user object, if we're talking about a user object, and then it basically takes a copy of all the data that's in the user object, apart from the thing you want changed. So if you want to change the first name, all the other things remain the same. But what you get back is a new object. It's a copy of the old object with just the first name changed, for example. So one of the benefits of doing that is that you can actually afterwards, once you've made changes, you can actually go and do a diff, operation on the two objects, and the before and the after one, and you can actually do that, diff operation to then figure out, okay, what actually changed. So if you want to persist the change in a database, for example, instead of trying to keep all sorts of dirty flags on an object itself, you can make a sort of like a diff comparison between the two objects or records. But what we normally do instead is that you could take this a little bit step further and say, instead of having to do all the work of doing a diff comparison between two values, what you can do instead is you can say um, all the operations that you want to perform on objects, on business objects, for example, like changing the first name, you could have that function emit a command or an event. So you simply just, instead of returning a new user object, you basically just return the events or the commands that would be the result of that, and then you can go and apply that to your persistent store instead, or you can apply it in memory. So that gives you some flexibility in terms of how you want to model the interaction between what happens in memory and what goes back into a database or document database or whatever else it is. I don't know if I probably went off on a little bit on a tangent there, so reel me in, please.
Okay, gotcha.
Yeah.
The weird thing is, and people on Twitch wouldn't see this because they could see me, but I hadn't turned my camera on for this meet, so you weren't seeing me.
Yeah.
But now you can see me. So
Yeah.
okay, let me move on to this other thing. In your book, you came across a couple juicy terms, which I think they're juicy terms: feature gating, the maybe monad, separation of concerns, and some other ones like that. And you don't devote entire chapters to those concepts. And I felt like I was like yearning for more information on those.
Right,
But
right.
obviously, your book is the perfect length. I loved everything about your book,
Good.
and you don't want it to be so long that it's overwhelming. So, what topics are there? Any topics in the book that you really wanted to expand on, but it would have made the book explode in size?
Yeah, well, so you just asked about the functional core imperative shell, and that is definitely something I could write an entire book about, and I'm actually thinking about doing that at the moment. But I didn't want to make the code that fits in your head. I didn't want to make that book into that topic, because that wasn't really my goal with that book. So that's basically just a thing that's mentioned in passing, saying, "Oh, you should really look into this because that might actually be quite helpful to you." But it's not that. It's not a book about functional core imperative shell. And even if you don't want to do that functional core thing, I still believe that there are a lot of other ideas in the present book that you can probably find useful. So just to give everyone a bit of an idea about what was the idea with the book. The idea with the book was basically just that I've spent years with various different development organizations, coaching them and sitting them with them and doing mob programming with various different people, doing code reviews for various different organizations. And over the years, I started to recognize that I was finding ways to explain things to people, and all sorts of heuristics and rules of thumb, where if they ask me, why do you want to do this instead of that, and I would say, I want to do it my particular way because I actually have some guiding principles that guide me, and this is then why I want you to avoid state mutation instead of returning a new object, or this is why I want you to write a test here, or this is why I want you to turn warnings into errors, or whatever it is. There's lots of different things. After I did that for many years, I thought, well, okay, maybe I should just collect all of those ideas into a sort of coherent narrative. So that's the idea with the book. So that's also the reason why, when you asked, was there something that we could expand on? Because there's lots of things we could expand on. why didn't I do that in this book? And that's because the point with this book is more like a catalog of ideas more than it's a comprehensive treatment of one specific thing. So that was the goal of the book.
Yeah.
But definitely, to get back to your question, something like functional core imperative shell, I could write an entire book about that, and that's probably that's probably the thing that's closest to my own heart at the moment. So that's I might actually do that.
Okay. I'm going to go off script a little bit here off of my list of
Sure.
questions, but functional core imperative shell, it's not a one for one, but I've often conflated that with what I call service oriented programming. Do you have any
Hmm.
pros and cons to the idea, or do you think that they're pretty close to the same concept, or what?
It's so service oriented is more as the way that I see it, that is more like a large scale architecture in the sense that um, well, unless you go into microservices, we can just leave that be for a moment. But if I think about more old-fashioned service-oriented architecture, I tend to look at that as more like a large-scale architecture. It's almost like enterprise architecture, where you have lots of you have various systems that may actually be programmed in. You could have one system programming Java and another one in C Sharp and one on Python and one in JavaScript, and they all sort of have to you know all together they have to be this ensemble of systems that accomplish some sort of business goal. um, that's when you say service oriented architecture, to me that's what I hear.
Okay.
But I'm also so old that I was actually a young programmer back when service oriented architecture, when that was a buzzword, and that's how we thought about it back then. So I take a lot of my ideas about what SOA is. I take a lot of those ideas from Udi Dahan, who defines a service as something like an autonomous, self-contained, thing that enables a business capability, something like that. I can't remember the exact phrase that he uses, but it's something like that. So that's more like a large-scale, architecture decision, which still might make a lot of sense. You just have to strip off all the XML and all the SOAP that sort of came with that territory back then. But the overall idea is not stupid. It's actually a pretty good idea if done right. So in terms of functional core imperative shell, I see that more as that's a small scale architecture, which is actually what I feel that I know the most about. I've sort of dabbled in large scale architectures, but typically I would defer to someone who knows more about that than I do. My specialty is like more in small scale, code bases, how to organize code bases. Um, and that's where I see something like functional core imperative shell. That's one architecture you could apply in a code base and say, okay, we're going to write this particular code base according to that general idea, which basically means let's minimize the amount of non-deterministic side effective code, and let's maximize the amount of pure functions that we have.
Okay.
And so that's sort of the idea there.
Yeah, I think I've conflated them because I came from a SOA background of large
Hmm.
enterprise architecture, but then
Yeah.
taking people from that into microservices. And
Yeah.
so I sort of brought the term SOA with me into a microservice where I then
Right.
said, we're going to be separating this out into imperative shell, functional core. And I sort of started calling that like a mini SOA inside of a
Hmm.
microservice. So I may have been conflating that for a long time, which may be my mistake. And I just think maybe it's easier to say this is a service, oriented architecture instead of saying this is imperative shell
Yeah.
functional core.
Yeah.
So maybe I shouldn't do that. Maybe I should just change my terminology a little bit.
I would probably not talk about microservices as being, imperative shell, functional core imperative shell, because everything, what typically happens with microservices is that they have to communicate with each other, either synchronously or asynchronously, and all that I/O that happens is that's by definition impure. It's either something that has a side effect or is non-deterministic. Um, so all the communication between microservices will be, part of the imperative stuff anyway.
Oh yeah, and I was
So
definitely trying to
yeah,
focus in on how the microservice is built internally, not like how the
internally, yeah,
architecture
no,
is.
and that makes a lot. You can definitely do, design or implement a microservice with that, style of thinking. Yes, that absolutely, yeah, that makes a lot of
Okay,
sense. Um, yeah.
perfect. I've got a audience question here.
Uh-huh.
What techniques in using C sharp? This is a .NET C sharp user group. What
Mhm.
techniques have you found useful to help encourage or enforce a more functional core kind of programming in C
Mhm.
sharp?
So the lowest hanging fruit that I've had success with, this is a few years back, was basically to get a team to agree that null was not a valid return value. Um, so it's not quite the same as doing full on functional core imperative shell, but um, it's a good step towards, in that direction. And nowadays, if you're on C#7, I believe, or later, you can turn on this thing called nullable reference types, where you can, um, you can say with your, return type that it's going to be nullable or not nullable, and it's particularly this the latter thing there, being able to say with a method, this is not going to return null. That's really important. But I'm sorry, I'm just getting some SMSs. I should have turned on my phone, and I just got a little bit confused by that. But they're probably going to be gone in a moment. So well, okay. So this is really something that can enhance your productivity quite a lot, because you often see people resorting to all sorts of defensive coding where they say, I don't know whether this value is going to be null or not, so I better, I'd better check to see if it's null, and then do some ad hoc, handling of, if a value is null. So it really saves you a lot of trouble if you can just tell by, a object's type whether it can be null or not. So back when I started doing that, we this was then, long before C#7. So instead of we couldn't say, that we could use the nullable reference type language feature, because it didn't exist. So what we did instead is we introduced this little, idea of a maybe of T, little generic container. So basically, you can think about this thing called maybe. It's also called option. Some languages call it option of T, some languages call it maybe of T. And you can think of this little container as it's basically a collection that is constrained, so that instead of having, 0, 1, 2, 3, 4 elements and so on, it's a collection that's constrained so that it can either have, 0 or 1 element. So that's the only two options that you have there. So instead of dealing with values that may or may not be null, um, you can model, the absence or the presence of a value in terms of having this maybe of T or option of T. So we introduced this little maybe of we called it maybe of T in this code base, and then we had this rule. We said, as a general rule, no return values are allowed to be null. If you return a null value, it's a bug in the method that returns the null value. So this means callers of methods should never have, they should never have to do defensive coding, because if the return value turns out to be null, you can always, you know, treat that as a bug in the code that returned the null value, instead of having to do defensive coding all the time. So once that team really got the hang of that way of thinking about things, they were really happy with that, because it took away a lot of the angst of, how should I deal with null values here, because you could basically you could tell, if you had, let's say a database query, for example, you want to query, you want to read, query for a user. So you pass, a user ID to a database query, and then you have this method that returns maybe of user. And that tells you have to explicitly deal with the absence of a user. But on the other hand, if you have a method that returns a user, not wrapped in maybe, but just a user, you know that you don't have to deal with the absence of the user because it's always going to be there. And if it turns out to be null anyway, you can file a bug in the method that returned the null value. So once they got the hang of that, they actually started to think about some other things that you could do in that sort of, following the same sort of philosophy. Because I made no secret out of that. Maybe of T is not something that I had invented. It's just something that I stole from statically typed functional programming. Because then the next one of the next questions that can come up is that sometimes you want to instead of just returning nothing, you want to return some sort of error code or some error message or error object that indicates, all right, you didn't get the user, but there might be various different reasons why you didn't get the user. So here is another data structure that's going to tell you, okay, why didn't you get the user? Because you might want to deal with the various different reasons in different ways. So that leads you to another thing from functional programming that's called either, or some people call it the result. So result of T, or result of T, or there's typically going to be two generic type parameters there, one for success and one for failure. But anyways, again, that's also just a well-known idea from functional programming. So they started adopting that as well because they understood where that maybe of T came from, and they got curious and started to look into what else can we do. So that turned out to be quite an effective way of getting people into thinking more functionally. That's your original question. Just to make a little short end on this, this team ended up going totally overboard with this. So I think I've posted some of the with permission, some of the code they ended up writing, where it was quite ridiculous in terms of they pulled in so many ideas from statically typed functional programming that if you didn't know statically typed functional programming, the C# code didn't really make any sense to you anymore. And that's where they decided, okay, let's just switch to F# because it doesn't really there's no benefit in staying with C# any longer, because you couldn't just take some person off the street and who says, I know C#, I've been a C# developer for 10 years, and you could if you try to take even a very seasoned C# programmer and dump them into this code base, they would be completely lost unless they knew functional programming. But then again, if you could find someone who knows functional programming, maybe a language like F# is a better fit. So that's actually what that team ended up doing.
I like that.
Yeah, so that's a little bit of an ironic twist, story twist there at the end. But that's so I know, very long answer to your question there, but just starting with this idea of trying to eliminate null as a thing that is legal in a code base, that actually takes you, it's not that it's explicitly has something to do with functional programming, but it's something that languages like Haskell and OCaml and F#, they pioneered this way of working with particularly Haskell doesn't have nulls at all. So they have developed lots of techniques for not they have different ways of not having null. So this is how should I say this? Having a good strategy for dealing with null is often a fairly low-hanging fruit in the sense that most teams don't like null reference exceptions. So if you come and tell a team that I have a fairly good way of avoiding null reference exceptions, you can get most teams to listen to what it is that you have to suggest, because that's always a pain. So that's one way you can sort of sneak ideas from functional programming in.
I love it.
Not that it's sneaky, but it's a good way. It's a good way to introduce people to ideas like that.
Sometimes you got to be a little bit sneaky.
Yeah, I didn't actually do it to be sneaky, but I just found after I'd done this that this actually works pretty well. So it's not that I had this grand master plan before I started out there. It's just turned out to be a good way of doing it.
Okay. Okay. There's are some other user questions, but I want to get to some of my
Uh-huh.
questions first. So in your book, you talk about cyclomatic complexity,
Hmm.
and that's the number of paths that your code could split off and take to create different paths conditionally and
Yeah.
whatnot. So you also talk about guard clauses in your book. I don't know if you're going to know where
Hmm.
this is going, but you also in your blog wrote about guard clauses, and you said something about some people don't consider guard clauses worthy of unit testing.
Ah,
I'm one
right.
of those
Yes.
people. I actually did a couple videos recently on that, as well as a video on the maybe monad, which I'd love
Hmm.
your feedback on. But we'll get
Oh
into
yeah.
that some other time.
All right. Cool.
So on the same note, I'd assert that a guard clause actually, since a guard clause signals the end of a path, it's like a conditional return, like hey, we're going to stop this path and get out of here.
Right.
I would assert that a guard clause doesn't add to cyclomatic complexity calculation, so it's not a
Hmm.
contributing factor. So I'm curious what your thoughts are on that, where a guard clause is the end of a path, it's not starting a new path. What are
Yeah.
your thoughts on that? On my assertion on that?
So you did mention a little bit about whether or not we should unit test it, and I think we could come back to that in a moment. A guard clause definitely adds to your cyclomatic complexity. That is, the definition of cyclomaticity, because well, the, the, the definition of cyclomatic complexity is that you have to count the branches and the for loops, and it is indisputably a branch in as far as I can tell. Visual Studio at least would agree with me because if you write three guard clauses and then have a happy path through a method, so that's three guard clauses and a happy path. I count that as four, and Visual Studio would also report to you that the cyclomatic complexity of such a method is four. So I think in that respect, I haven't seen any other take on cyclomatic complexity that doesn't count the guard clauses. So I would definitely say that they do they do factor in. But then again, if you can, if you have, let's say you have, let's just say you have three guard clauses, where you check for three different things, but in all three cases you do the same thing. You throw in an exception or something like that, or maybe you return a null object. If you then go and extract those three guard clauses into one helper method that then throws the appropriate exception, maybe something like that. Then again, Visual Studio would then agree that then you have just one guard clause, even though that helper method itself has a cyclomatic complexity of maybe three. So you can definitely hide the way that cyclomatic complexity is defined is very explicitly on the branching visible in a body of code. So if you have a call in one of the branches, if you have a method call that then calls into something else that has a cyclomatic complexity of, let's say, 42, it's not like you have to take those 42 and add to whatever it is that you're counting inside of your method. Cyclomatic complexity is defined as being just what you can actually see inside the method. So what's hidden behind calls to other methods or calls to other procedures and so on, those don't count. So in terms of guard clauses, for example, you could probably hide some of the multiple branches in a guard clause in a helper method, and then reduce the cyclomatic complexity a little bit.
Okay.
Um, I've never heard the argument the other ways that you just gave. That's the first time I've heard that.
Yeah,
So
I
I
was
think,
curious if you'd heard that before, and
yeah, yeah.
I want to dig into that at some other point. I don't want to take
Hmm.
the rest of this talk,
Okay.
and maybe even have like a roundtable discussion. Maybe you're there, but maybe just some other people, and I'm curious if I can make my point to say certain guard clauses at least don't count toward it. But I was just curious if you'd heard it before. So
Yeah, we don't have to go into this, but we can always return to it later on, because but you did mention unit testing also, and I've been going back and forth over my career on whether or not I think you should unit test those. So we can always I wouldn't necessarily say that you always have to do that, but that's another thing. We can always get back to that if you think that's an interesting discussion.
I do, but I do have other questions also. So
That's okay. That's okay.
Okay, so your book follows a fairly common pattern of having DTO objects on the front boundary, and then
Hmm.
those DTO objects are translated into domain models. It's also possible that there's similar models. So there might be models inside of an SDK project, perhaps, or on the back boundary you have entities that are related to the database,
Hmm.
and these models all look the same, and so you have duplication. And
Right.
I think I know we're going to go with this. I just want to have the question out there on a stream. So in that case, there's copies everywhere. Some people will say, "Why do I have to have all these copies of the same thing?"
Right.
And I don't want you to repeat the same things that you wrote about directly about the DTO to the domain model.
Hmm.
But at a bigger scale, you also have entities. You also have SDK models, possibly, and some view models, and all these different things. So what's your high level pushback or against that?
Yeah. So it's a so first of all, this is a topic that's I I'm probably gonna wrestle with on my deathbed as well. This is a really difficult topic, and so what I'm gonna tell you next is probably not gonna be my final word on this. It's just what where I am with this after I'm in my third decade of programming now, and I've changed my position on this particular question many times. But I think I've reached a point where it makes some sense to me, at least. Um, I have increasingly become disillusioned by having too many types that model the same thing. So for example, I don't really like object relational mappers. I tend to avoid them because I think they make things more complicated. As they create more problems that they solve. But so people would often ask me, for example, so what do you do then if you can't have object relational mappers? And I say, well, what I typically just do is I just fall back to straight old-fashioned ADO, the ADO, the objects. What do you? I don't even know what that acronym is anymore, but it's been around since basically .NET 1. This thing with you have a SQL command and a SQL connection, and the SQL command you can put parameters on that, and then you just fire that off with a string which is just SQL basically. Um, and I find that useful in many cases, but it's not that you don't have copying of data structures from one place to another. It's just that I don't have an object that represents. Let's again go back with the ubiquitous user example. So let's say we have a user with a first name, a last name, and a display name, and an email address, and probably some other properties as well. So what you would do with an object relational mapper like Entity Framework, for example, is that you would have an object called user or user record or something like that with those first name, last name properties and so on. But if that's not your domain model, which I think it shouldn't be, then you need to go and do copy the domain model's first name to the entity's first name property, and copy the last name to the last name and so on. So there's all this mapping going on. If you don't have the entity, it doesn't necessarily mean that you don't have to do the mapping. You still have to do the mapping, because even if you do ADO.NET as I do, you still have to say, okay, so the first name property from the domain model needs to go into a SQL parameter called first name. It's just called at first name, because it's now a T-SQL parameter instead of being a C# object property. But the mapping still needs to happen. And also, when you read from the database, you get a SQL reader back, and then you need to index into the SQL reader and say, okay, the column called first name, I will now map to to the first name variable in my domain model. So the copying still needs to take place. So this is basically just to say, this is one of the reasons why I still think that that I'm not done with the question that you just asked, because it seems to me that there's always going to be some mapping going on. So why are we having those different representations of the same data? Might be a good question to ask ourselves, because I've often seen lots of architecture diagrams where people would basically say, well, we have these layers, we have the user interface layer and the business logic layer in the middle and the data access, the data object, the data access layer in the bottom. And then you have this sort of, excuse me, this vertical thing going on where, I've seen, a diagram like that a lot where, the vertical thing that cuts across everything is just called entities, and the entities will go all the way, from the user interface down into the database, and that would typically be defined by something like, entity framework or something similar. So why not do that? And I think one of the reasons why that's not interesting, or why that's dangerous, is that it it robs you of a chance of having good encapsulation. So instead of talking about databases, let's talk about what comes in at the application boundary. So I typically do REST APIs. That's what I mostly know about. But you can imagine something with the user interface as well. But when you receive data that from the real world, in a REST API, for example, you get data that's not really been validated yet. So it could be basically anything. And maybe you have some framework stuff where you say, okay, I'm gonna, in a REST API, you might say, we can receive JSON or XML. And if the input is not formatted as JSON or XML, let's say the ASP.NET system is just gonna, tell the caller that this is a bad request. So you do know a little bit if you actually receive an object that has been dehydrated or been read from JSON into a DTO, you do know that at least it was valid JSON. So it does tell you a little bit, but that's basically what you know. You don't know much more than that. You can again annotate some things where you say, okay, this property, particularly with the nullable reference type, option. Now you can say, oh, this string, which is the ID, should always be there because it can't be null. So you could do, a few things like that where you can annotate various different properties by saying this should always be there. But since a transmission format like JSON, for example, it's very limited in what you can actually express in it. So just something like a date, for example, a date and a time, you would typically transmit that as a string, and you could transmit that as an ISO, what is that, 8601, I believe the ISO code is. So you could transmit that as some sort of well-known date and time format. But when you receive the object, and there's an example of that in the book, when you receive like something like a reservation, for example, you need to know the date and the time for the reservation, but it's just a string, because that's all JSON can model. So now you need to have a look at that string and then figure out whether you can pass that into a real datetime datetime value in C#, for example. So you could write some validation code that validates whether that string is actually looks appropriate. But if you only do validation where you say, okay, here's the validation method that says true or false, this input was good and versus this input is bad, you're sort of throwing away the parsing that you just did. You had to parse the string in order to figure out whether it actually represents a proper date and time. But then if you only return a Boolean value afterwards, you just lost the information that you could actually have parsed this string into a stronger into a type with stronger semantics. So there's this idea of, instead of just validating things and figuring out whether they're true or false, you say, all right, I want to capture that this DTO represents valid input, and how do I capture that knowledge in such a way that all the other recipients of that object, they know that they don't have to do validation again and again. They don't have to check for malformed values and so on. They don't have to do defensive coding. How do I communicate that this is already okay? And this is the idea behind encapsulation. This which is an old idea. Encapsulation is this idea that an object is always in a valid state. So basically, we can say DTOs, their definition of a valid state is basically just that they sort of, you know, capture something that can go on the wire. So if you have, in my book, for example, I have a reservation DTO, and the only thing that we can say about a reservation DTO is that it serializes into to correct JSON, and it can be deserialized from correct JSON into a reservation DTO. But apart from that, we can't really say much more about it, because what that means, you know, that's its definition of validity. It's basically just, does it, you know, does it map to a JSON document? Basically, that's what validity means for the DTO. Whereas if we look at a reservation domain object, it has further rules associated with it. For example, we say the date and time for the reservation is not just a string; it has to be a valid, you know, date time value. And we can also say the quantity requested for the reservation must be a positive number, which is again something in the DTO. You know, you could have a JSON document where the quantity is set to -42, and that would be valid in the sense that this is something that is transmittable over an HTTP request. Whereas we can say that's not a valid reservation, even though it is a valid JSON document. So being able to capture that, that you've done some extra, you know, checks on the data that was inside of the DTO, you want to be able to model that in such a way that that every other, you know, client code that has to deal with the reservation, they just automatically know that all this data input validation has already taken place, and the object that you're now working with is guaranteed to be in a valid state. So that's why we have those translations between, you know, you have the DTO, which represents the very weak guarantees that you're being given by, you know, the transmission protocol, and then the much more, you know, the stronger guarantees that that something like validation can give you. So that's why we need to have both of those, because they play different roles, they serve different purposes. That's again a very long answer to your question. So I'm sorry, sorry that I can't just do it in 2 sentences for each question. But I hope that makes sense. But, you know, again, I've tried to explain those ideas, you know, more, and sort of try to lay down in the book with even more details and lots of examples.
Okay. All right. Yeah, that's really good. I think it's basically they change for different reasons. So even if the properties look the same, they change for different reasons. Okay, so when this, I want to jump to this because it's one of my questions I definitely wanted to get to, even though I'm skipping around and moving some things possibly. When you put validation logic, this is somewhat related to what you're talking about, comparable and other types of code that does validation to make sure the state's good and all that sort of stuff. When you put that into an otherwise anemic domain model, do you consider that object-oriented programming? And I think what I'm really also getting at is if you're doing the bulk of your code is, let's say, functional core, imperative wrapped, and then also, like one of your blogs say, the boundaries of your application aren't object-oriented. So how much of your code that you're doing is object-oriented is what I'm curious about.
This really depends on your definition of object-oriented. I would say, you know, if you take a look at the source code, the sample code that is, you know, that accompanies the book, I would consider that to be fairly state of the art in terms of how I would do C# programming if I had to also take into account that there's a team that needs to understand what's going on there. You know, there are some things I could have done more in a more sophisticated way, and again, but, you know, if I wanted to be very sophisticated, I could have written the code in F# or in Haskell. But if I'm taking into account, you know, the way that I tried to write the code in the book was thinking about, okay, so if this is a team, you know, if this is a code for a team that is, you know, that consists of, you know, colleagues of mine that are curious, they want to learn, but they may not be. They probably don't know all the things that I know. They know other things that I don't know. But we have only a small intersection of all the things that we all know that we have in common. If I wanted to target a source code base at that level of developer, that's basically how I would write the code, the way that I've written in the book. So I'm not doing very sophisticated things in terms of a lot of generics and a lot of functional programming techniques. I use a few, but not that much. But there's probably people who would say that it's not object oriented because there's so little state mutation going on. Everything that needs to model a state change would basically be take a copy of the reservation, for example, and then return that copy with the few things that had to change, and then apply those to the database again. So there's a lot of things like that going on. Lots of querying where you can ask objects about various things, whether reservation can fit on a table and so on. But it's all based on a lot of deterministic query based reading getting data from other objects and so on. And there's almost no state change going on there. So whether you consider that to be object oriented or not, that probably depends on your definition of object oriented. I think it's quite nicely object oriented. If you ask me, I think it's object oriented. Robert C. Martin has this idea about object orientation and functional programming not actually being at odds, but are more like they're sort of like perpendicular, independent things. Where his position is that you can do object oriented functional programming, and to a certain degree, I think he's right. I don't think they're completely independent, but it's not like you can't, it's not that you can't mix them. And I think what I've done here is a fairly decent mix where I think if you just came into the code base, but I don't know how much chance you've had to look at the code base, but I would guess that if you come into the code base and you don't really know what to expect, you'd probably say, oh, this is a little bit unusual in the way that it does things, but I still get it. That's my hope anyway. But I try to design it in that way where you wouldn't, or you shouldn't go to it immediately and say, oh, this is functional programming. You would probably just go to it and say, yeah, this is a little bit of an unusual take on object-oriented programming, but yeah, I still get it. That's my hope, anyways. Again, I think I'm drifting off from your original question. So bring me back in. What was your original question?
I think you pretty much answered it perfectly.
Oh, good.
When I looked at your code base, I'm like, this looks like code that I write. This is code that I write, and it's like you said. I don't want to go too far off the deep end, getting super functional, because
Right.
you're gonna lose a lot of the job market out there. You're gonna have to rehire developers. It gets crazy. But I've also been to a lot of clients where I say, hey, let's do things in this way, and especially their older developers say, you're breaking all kinds of object oriented rules. This isn't object oriented. And
Right.
so I have to sort of push back against it and say,
Yeah.
I realize it's not exactly what it was, in the 90s and whatnot, which, I mean, you and I both were developing in the 90s. So I know it's not the same thing, but this is the way we need to be moving. And I get a lot of that pushback that it's, and I have to agree with him. It's not object-oriented programming in the purest way from 20 years ago. It's different.
Yeah, but again, the discussion always comes up. What would Alan Kay say? Because once that discussion comes up, people will ultimately bring up Alan Kay and his idea of object orientation, which, as far as I understand it, is a completely different from what we actually got. So one thing you could probably one thing that I try to tell people when they say it's not object oriented is that I try to understand what sort of object orientation they have in mind, and often it's an idea about object orientation that has its origins in maybe in C++, or maybe in a particular flavor of object orientation that they picked up from Java and early Java style architecture,
Hmm.
um, which is one interpretation of objects orientation, but it's not. It seems that it's not really what Alan Kay originally had in mind. And also, if you go back and read something like Bertrand Meyer's object-oriented, what's it called? Bertrand Meyer has this book. He's the guy who created Eiffel, and he has this book from the mid '80s called something like Object-Oriented Software Construction. I think the title is. Um, and this is where he outlines, for example, when I talk about encapsulation, this idea of being that encapsulation is defined by an object must always be in a valid state. That's his idea. That's what he writes back in the mid '80s, saying, well, that's how we define an object. It should always have it should have a contract. The contract should specify what is valid, and it's the object's responsibility of guaranteeing its or upholding its part of that contract. And I think if you go and look at some of those naysayers that you're talking about there, if you go and look at just if you just casually browse through their code, you will probably, my guess is, you'll probably find lots of places where they break encapsulation left and right, because they allow objects to be initialized that are not in a valid state when they're being initialized, and all sorts of things like that. So you can always I don't say this is a good strategy, but I think you'd always shoot back at those people and saying, well, yeah, but what you're doing is not object oriented either. But at this point, you shut down the discussion. So it's probably not the best way of leading with. But if they get very obstinate, sometimes you can start to have those discussions where you say, yeah, what is really object orientation when we there are different takes on it, and there's one style from C++ and Java that became very prevalent, but it's not the only interpretation of object-oriented programming. There are other interpretations out there that might actually fit better with something like what I present in the book.
Okay, yeah. I think my main attack vector, or defense vector even, is that a lot of people, a lot of people will say, okay, I'm going to go back to what I said earlier about service-oriented programming, is like what I was trying to talk about. You have a service, and like what you said, you might have an object like a user. You pass into the service. It might do some things internally, maybe functional, maybe imperative shell, and it'll pass you back an object perhaps. Whereas old school object-oriented people will say you have the user. The user should be the combination of state and process, and so it will do its own process. It might send a message off to something else to say save me in the database, but it's saying save me in the database. So I sort of make those the contrasts of the lines. But I love your idea that if we just simply say you could consider this object-oriented programming if you say object-oriented programming is whenever you create an object, that object is always in a valid state. I think that's it's fairly simplistic, and it's really easy to follow, I guess, with that type of rule.
Yeah, that's the idea behind encapsulation, but most people see this idea of encapsulation as being very, very core to the idea of object-oriented programming. So you can always say that this is the idea from Bertrand Meyer's book from the mid '80s, because it's true, but also no one has read that book, so so you can always just tell them that's the case. Now, that's probably a little unfair, but it's actually, I picked the idea up from that book, because I think it's a nice way of this is actually a one sentence explanation of what is encapsulation. Well, it is guaranteeing that the object is always in a valid state. It's it's a fairly easy concept to get across.
Okay, I did have some input from from the audience. So, given your experience with software development as an engineering discipline, I don't mean to put that in quotes. It should be the norm that it's an engineering discipline. It should not be a quotable thing. But given your experience as an engineering discipline, where do you see an engineering discipline headed? So, given the popular growth of facilities like artificial intelligence and the limitations of human cognition and whatnot, where do you see that proceeding as an engineering principle?
Right. So there's this guy called Hillel Wayne, which whom I follow on Twitter, and he actually did something interesting in that regard, because he did a set of interviews with various different engineers who had started out being, if you will, real engineers, construction engineers or electrical engineers and chemical engineers, and then they crossed over into software development. So he did a set of interviews with those people, and tried to talk to them about what they found was, what commonalities and what was different between real engineering in air quotes and software development. And he think so he has a 3-part blog post series that you should definitely go and read if you're interested in that question. But he found that, first of all, real engineering is probably, it sounds like real engineering is more, or it's rather, it's less disciplined, and it's less, there's more room for creative work and winging it than we software developers probably normally think of. There's actually a lot of creative work going into real engineering. They do have some extra things that we might look towards and learn from. But Hillel Wayne's conclusion is also that we actually have some things that they're very envious. For example, and the most profound thing that everyone else should envy us is source control. We have, with Git nowadays, we have source control pretty much figured out, and we are probably the only profession in the world that has figured out this problem. Everyone else is struggling with this problem, and engineers do that as well. They have all those, uh, the diagram, the final draft diagram part 1, final diagram, final part 2, all those things where files are just being emailed around and things like that. So they could definitely learn from us, and that's what they, at least his informants, that's what they told him. But I think, and one of the reasons why the book is called, it has the subtitle "Heuristics for Software Heuristics for Software Engineering," is that I think a lot of the ideas in the book are extra things that you can do to make a software development process a little bit more um, predictable, if you will, or more manageable. And I start very simple, like things like use source control, use Git. But I suppose everyone does that. Almost everyone does that these days. So that's a very low hanging fruit. But then and this is in chapter 2. So very early on in the process, I say, well, there are things you can do that most people just don't do. But I don't know why they don't do it. And this might be something like taking all the warnings that the compiler will emit. So the C# compiler emits lots of warnings if you do various things that are suspect. And there's this flag you can just turn it on and say all warnings should be errors. And that means if you have a compiler warning, your code doesn't compile. And I don't know why people don't do that, but that is a very simple thing where you can say it's already there. There is knowledge built into the compiler. Those warnings are very rarely wrong. If you look at a C# compiler warning and actually understand what it is that it says to you, you will 99% of the time want to fix the code, because that's not what you thought you were doing something, but the compiler is telling you, yeah, it's probably not what you think it is doing. This is probably not going to do what you think you're doing. Are you sure about this? And then you look at it and you say, no, actually you're right. Thank you, compiler. I will now change the code.
Yeah.
So this is just one example. There are myriads of those examples where you can say there are things you can do where you can add a little extra level of discipline to your process, and some of them are tools driven like this, where you can just ask the compiler to help you out, and sometimes the extra things you can do is more they're more process oriented. Like, for example, again, most engineers will have some sort of sign off process where when they make diagrams and so on, they might actually have someone else to look at the changes that they made and sign them off and so on. And we have that as well, or we can do that as well in software development. We call that a code review. And I've met organizations who do code reviews, and then I've met most organizations don't do them. But again, I think it's one of those things where it's a step towards being more, behaving more like an engineering team if you adopt some of those practices. So again, the idea with the book is that it's meant as a catalog of all sorts of different ideas, and I'm not saying you should adopt all of the ideas in the book, but you can read the book and get a sense of some of the things you can do, and then you can adopt the ones that you feel will improve your own organization. And then I'm not at all claiming that the ideas in the book are that those are all the ideas that are. There's going to be plenty of other ideas that I just didn't think of, or that other teams have thought of, that again will make the development process a little bit more predictable, if you will. Something that I didn't really mention, I may have mentioned something like A/B testing just in passing in the book, but it's not something that I go into because I have to admit that I have no practical experience with that myself. So I thought, well, I should probably leave that alone. But that's another thing. That's another thing you can do, where lots of people have reported that A/B testing has really worked wonders for them. And again, it's a great way of adding some extra. And some heuristics, a bit of methodology into the process that can guide you towards making good decisions, which I believe that's ultimately what engineering is about, as far as I can tell. It's get as much process in place so that it enables you to make good decisions. I think that's probably a good way to phrase it.
Nice.